Hello students, I hope you all are doing well. So today in this class I will explain the mirror formula. Okay, we need this mirror formula to calculate the or to solve the numerical problems related to spherical mirrors. Okay, so this in this box we have a formula which consists of 1 by f equal 1 by v plus 1 by u, which is known as mirror formula, and where f is stand for focal length and v is stand for distance of the image and u is stand for distance of the object. Okay, so by knowing any two quantities, suppose we have to calculate the focus here, then by using these two quantities, image distance and object distance, we can calculate the third quantity. Okay, so by knowing any two quantities from this formula, we can calculate the third quantity. Okay, and there is another term related to this mirror formula which is known as magnification. Okay, this magnification is represented by small m. This magnification is nothing but a simple ratio of the height of the image to the height of the object. Okay, we know that we have different height of the image and object according to the different position. Sometimes we get a highly diminished object or point size object, or sometimes we get same size, and sometimes we get enlarged, okay, or highly enlarged. So according to their height, we have a ratio which is called magnification. This is the expression for this magnification: hi by ho, m equal to hi by ho. Here hi is stand for height of the image, I is stand for image, and ho is the height of the object, o is stand for object. Okay, again this ratio is related to the object distance and image distance like this. Okay, magnification is equal to height of the image by height of the object equal minus v by u, distance of the image by distance of the object. So these two formulas we are going to use in a numerical problems, but according to the directions of image and object and also focus, we have there are some sign conventions. Okay, we have some sign conventions which we have to follow. This is called new Cartesian sign convention, which we have to follow when we are solving a problem. So now let's see what is this sign convention here. Now look at this diagram. This is a concave mirror. Okay, this is a concave mirror. Here this is a rough surface. This is a back side of the surface or the rough surface, and this is the front surface or reflecting surface. Okay, so in this diagram we are going to apply the graphical rule, which is we know that the graph, when you draw a graph, we simply follow the four quadrant method, where when we use this four two axis, x and x and y dash. Okay, so in this x and x dash and y dash axis, when we consider values, when we put values in this direction, we put all the positive values, is not it? And in this value we put all the negative values, and in above direction we put all the positive values, and in the below direction we put all the negative values. So similar to that, this we will use the pole. This is the origin. We know that this is the origin. Okay, so similar to the this positive and negative direction, we will use this method in mirrors. Suppose here in this diagram, if we consider this pole as a origin, then you will see that we have four axes again: right, left, up, down. Okay, we have four direction again. If we consider this pole as an origin, then when we consider or when we measure any value from the pole to the right, we have to take it as positive. Okay, we have to take it as positive, and when we measure it from the pole to the left, then we have to take it as a negative. Okay, then again this is a principal axis. If we consider it as a principal axis, then from the principal axis to the in upward direction, okay, then the height, suppose the height of the object. Okay, so height of the object, if we take the height of the object, then it is positive because it is going in upward direction. Again, if we measure the height of the image, then in downward direction we have to take it as a negative. That means HO will be positive, HI will be negative. Okay, and here we can compare these two values, two sign convention in case of concave and convex mirror. Okay, let's see if we compare these two values according to the sign convention. Now look at here, we have two mirrors, again concave and convex mirror. Okay, so if we apply this sign convention in concave mirror, you will see that the focus is the focus, this is the pole, and this is the center of curvature. Okay, so you can see that this focus is lying left side of the mirror, that is from pole to the left. Okay, and here in case of convex mirror, the focus is lying behind the mirror, because now this is the reflecting surface, this side is the reflecting surface, and this side is the rough surface. Okay, here the focus is lying pole to the right. Okay, so pole to the right and pole to the left. So when we consider it is the right direction, that means the focus is always positive in case of convex mirror. Okay, but in case of concave mirror, it is always negative, because it is lying, always lying. Okay, always lying in front of the in front of the mirror, which is in the left side from the pole. Okay, so pole to the left focused negative, pole to the right focus positive. Okay, again now consider about object, okay, which is represented by U. Again U for object, and in both of the cases, like in both concave and convex mirror, we put the object in the left side of the image, left side of the mirror, is not it? Okay, if we consider this is the object, then we will see that from pole to the left, it is always lying in the pole to the left. Okay, in both the cases, pole to the left. Okay, so we have to consider it as negative because it is in the left side direction. So U is negative for both concave and convex mirror, because it always in the left side of the mirror. Okay, now image. Okay, we know that we have different types of image. We already explained in the 4 and 5 diagrams. We have according to the different position of the object, we already know the different position of the images. Okay, so here in case of concave mirror, we know that it can from both real and virtual image. Okay, both real and virtual image concave mirror form, and convex mirror always from virtual image, no matter where we place the object. So here if we consider it is a real image, okay, the image is real, so we know that when we put an object here in front of the mirror, we get the object we get the image in front of the mirror, then it is a real image. Okay, so for real image in case of concave mirror, we get this in front of the mirror. Okay, so that's why it is considered as negative. But in case of virtual image, in case of concave mirror, we know that when you get a virtual image, it is always from behind the mirror. Okay, here. So for virtual image, in case of concave mirror, we have to take it as positive. Okay, for real image, we have to take it as negative, because we get this in front of the mirror, and we get this virtual image in behind the mirror. Okay, and again if we consider in case of convex mirror, for image, we see that no matter where we place the object in front of the mirror, we always get a virtual image. Okay, we always get virtual image. So again pole to the right, we have to take it as positive. So in case of convex mirror, the V is always positive. That means the image distance is always positive in case of convex mirror. Again the height, okay, height of the object, okay, height of the object HO. So HO is always positive because when we put an object, it always directed in upward direction, which is erect means. Okay, and for real image, it is always directed in downward direction. So for real image, height of the image will be negative. Okay, for real image, height of the object will be negative because it is in front of the mirror but in downward direction. That's why height of the image always negative. But when we get a virtual image, then it is in the upward direction. Okay, though it is in the right side, but it is in upward direction, so we have to take it as a positive when it is in upward direction height. Okay, so these are the sign convention we have to follow when we are solving a numerical problems. Okay, so again we have another term, magnification. Yes, which is related to height hi by ho. Okay, here when hi, this is the height of the image, is equal to height of the object, then we will get 1, is not it? We will get 1. That means the height of the object is equal to height of the image. Again, if the height of the image is greater than height of the object, then we will get a value which is greater than 1. Okay, because here the numerator is bigger than the denominator. Yes, numerator is bigger than the denominator, like 2 by 1. Okay, here 2 is greater than 1, that's why the magnification is also greater than 1. Okay, that means the here the image is enlarged when it is greater than 1, and when the hi is less than ho, we will get the value which is less than 1. That means 1 by 2, suppose. Okay, then here the image is less or smaller as compared to the object. That's why it is in less than 1, but means it is in decimal. Okay, we'll get the value in decimal form. That means it is diminished. Okay, again if we compare the magnification with respect to the distance, which is v by u, from this we can evaluate whether it is a real or virtual image. Suppose for real image, we know that for suppose concave mirror, real image which is lie in front of the mirror, okay, pole to the left, that is it is v is negative. Okay, and as I told you before that u is always negative because it is always lie in front of the mirror. So magnification will be like this, minus is already there, so minus v by minus u, the minus will cancel out here, then we will get the value in negative. So when the magnification is negative, the image is real, okay, for concave mirror. And when the magnification is, suppose now the image is lying behind the mirror, okay, from pole to the right, then we have to take it as a positive. So now magnification will be, minus is already there, plus v by minus u, then minus will cancel out, then the magnification will be in positive value. So for virtual image, the magnification is positive for concave mirror. Okay, and this positive, we will get this positive value always in convex mirror because they always from virtual image, is not it? And also this magnification is less than 1 here because they always from diminished, means the height of the image is always less as compared to the height of the object. Okay, That's why the positive magnification but less than 1, it is a image from by a convex mirror. Okay, so from this magnification we can say, or we can determine whether it is a concave or convex mirror. Okay, to understand this or to use this in a example, let's see an example. Okay, so now we are considering a concave mirror here. So this is a concave mirror, this is a front surface, this is a rough surface. So in this mirror we are putting an object. Suppose the let or suppose the object is at 10 centimeter away from the mirror. Okay, so as we know that we have to measure the distance with respect to the pole, then pole to the left we will take this distance as u equal minus 10. Okay, because it is in left side direction, that's why it is minus 10. Okay, now because of this object it will form an image here. This is the image where the both 1 and 2 rays are intersecting. Now the image, suppose image distance is 4 centimeter. Okay, and which is lying in front of the mirror, then again b is equal to minus 4 centimeter. Okay, then again focus, as I told you that in case of concave mirror focus is always negative because it is lying in the left side direction. Then f will be in, suppose if the distance is 3 centimeter, then it will be minus 3 centimeter. Okay, so by using these methods we can calculate the numerical problems. Okay, I hope you understand. Thank you.